SB leads and dear attendees, a very good evening all present here. We hope all are safe and wish to stay safe and healthy. Before we start off with the session, I would like to request all the attendees to stay with us in the session till the virtual photo session at last. Encouraging and giving qualified and competent women an opportunity to rise does not depict failure of men. Rather, it shows the women's readiness to achieve, succeed, and develop. As part of Women in Engineering Day celebrations, IEEE RAS Kerala chapter invites you all to the session on women engineers, career in space and robotics. I now invite Dr. Disha VR, Chairperson of IEEE RAS Kerala chapter, to deliver the welcome address. Ma'am, please.
Yeah, thank you, Rosmia. Very warm good evening, everyone. Women in Engineering Day is an international awareness campaign celebrating the work and achievements of women engineers. So it's a time to encourage girls to consider engineering careers. So even though we see a lot of girls studying engineering, how many are taking up the profession in engineering field? Too less, right? So today we have with us an eminent women engineer, Dr. 𝙤𝙤𝙢𝙬𝙤 𝙬𝙬𝙬𝙬 Global Chair in Robotic Engineering at University of Lincoln, UK, and Head of Industrial Digitalization and System Intelligence Research Group to inspire all of us. Previously, she was the Head of Robotics and Control Research Group at the Surrey Space Centre, UK. Her expertise is in modeling and control of spacecraft, design and control of rigid and flexible manipulators, systems engineering using model-based systems, systems engineering approach, design and control of wheeled and legged planetary rovers, biorobotics, and flexible medical robotics, etc. And Professor Saj has secured research grants worth €4 million as lead and co-investigator. In addition to publishing 100 articles, she has successfully supervised several postdoctoral research fellows and PhD students. Being a leading female space engineer and roboticist, Professor Saj actively promotes space engineering education. She was a flying lecturer with the Engineering UK for Engineers Make It Happen campaign during 2008-2010. She won the Airbus Royal Academy of Engineering Secondman Award in 2009 and the University of Surrey Vice Chancellor's Teaching Excellence Award in 2013. Professor Saj is a chartered engineer with the Engineering Council UK and a senior member of IEEE and AIAA and a member of IEEE Women in Engineering. We are very fortunate to have her with us today, and we extend a great welcome to Professor 𝙤𝙤𝙢𝙬𝙬 Saj. Hearty welcome, Professor.
Thank you. Thank you very much, Disha.
A gracious welcome to all my colleagues in the EXICOM and student leadership team. And let me extend a grand welcome to all the SB leads and everyone participating in this session. Thank you. And over to Professor Saj.
Thanks for the kind introduction, Disha. Ellavarkkum namaskaram. I wish I could continue my presentation in Malayalam. It's difficult. So for that reason, I'm going to continue in English. I'm going to say a few things today. It'll be a short lecture, probably 30 minutes. And I would love to take up more questions if you have any at the end. So today, considering that we are celebrating the International Women in Engineering Day, I would like to share my journey as an engineer who specializes in space engineering or space systems and robotics. And I would like to also tell you more about some of the career opportunities out there for you as an engineer. So let's take a look at what I do in University of Lincoln. As Disha said, I'm leading the Industrial Digitalization and Systems Intelligence Research Group there. And as part of my day-to-day activities, I work with my colleagues from different schools and also with several industries, including Siemens, Airbus, and several other large and small industries specializing in space business and aerospace business, and obviously several companies developing robotic and autonomous system solutions. So as part of my day-to-day job, I specialize, or I lead several research projects connected with robotics and robotics, automation, and AI, or autonomous system solutions. And in Lincoln, I'm part of the Lincoln Center for Autonomous Systems, which specializes in both robotic manipulation and mobile robotics. And we work on a range of cross-sector applications covering space engineering, covering other Earth-based applications such as agri-food, nuclear industry, medical applications of robotics, and so forth. So if you look at what I do at this level, it's a long journey, to be honest. So recalling back my days at school, I would say that my interest when I was in the junior school was to really become a medical doctor. For some crazy reasons, I was very keen to have this doctorate or the doctor title. I didn't even know, what it meant, but I was quite keen to have this DR, or the doctor title, along with my name. So when I got admission to do electrical and electronic engineering at CET, I was very delighted because I thought, that'll help me gain a job at the Indian Space Research Organization, or ISRO, which I believe all of you know about. My dad, he worked at ISRO, and it was a really big dream at that time for me to work for ISRO. Fortunately or unfortunately, I did not get that chance, but I'm really glad I'm working in the space domain, and I'm specializing in robotics, automation, and AI. Now, as a child, I did, enjoy maths, although physics was a bit hard for me. Again, that did not stop me from pursuing my engineering career. And we had great teachers at my school as well as at CET who helped me learn all these difficult subjects. And it helped me really become a professional who is now internationally recognized. So thanks to all my teachers for supporting our education. Now, if you look at my journey from my school to CET, thereafter I had the fabulous opportunity to do my doctorate or PhD at IIT Bombay. I recall the golden days I had at IIT campus. Which was indeed a turning point for me, because that was a time when I started realizing the importance of research and what, as a control engineer, I can do in the research and industry sectors. So when I did my control engineering in CET, that was the time I was really looking at opportunities to see, how best or what I can do to excel and gain a job at ISRO. But control engineering is an area that is applicable to several sectors. So although at that time, I only knew about a career in space, I now realize that control engineers are very well valid for everything that happens on Earth. Every application has some form or other of control. And therefore, I was very pleased when I started doing my research in control systems at IIT, because I started applying this know-how or the knowledge I had in control engineering to different applications. And I started learning more about robotics on my own, because we were not taught anything about robotics during our BTech or MTech degree program. So it was a journey, it was a self-trained, I would say, initiative, and started reading more books and reading research articles on robotics and its applications. And gradually I started learning and started loving the field of robotics and autonomous systems. So once I completed my PhD at IIT, I had a great opportunity to join the Technical University Hamburg-Harburg, where I specialized in robotic system identification and control, and had the opportunity to work on industrial manipulators for the very first time. So that was an eye-opening experience for me. And thereafter, I had the opportunity to work on unmanned vehicles or UGVs at King's College London. And thereafter, again, I was looking for a really interesting job where I can specialize in space systems. So I was lucky to join the Surrey Space Centre back in 2005 as a research fellow and started working on projects funded by the European Space Agency and various other UK research councils and industries. And I had the excellent opportunity to work on also project funded by NASA, where we worked on developing lunar planetary landers. I had I was also part of another interesting project on satellite formation control funded by the European Space Agency. And we had a wonderful journey, I would say, where I had this rare opportunity to work on so many different areas of space systems, not only satellites, but also looking at the design and operation of space robots, which is much more complex than a conventional satellite. So if I look back at my journey, I would say the most fascinating part is this the real challenging domain I am working, which brings together space engineering, or the experience I have in control engineering, and how I apply that to space systems, to robots, and we have the opportunity to apply those skill sets to different sectors, not limiting myself to space, but I also work in other domains. So that's a very interesting journey. And although I'm part of the academia, I had a fabulous experience working in industry. So I went on secondments to work with Airbus Defence and Space, and I also did a secondment with Surrey Satellite Technology Limited. So those were a great experience for me to gain more hands-on experience working with industries. So whilst I'm an academic teaching students, doing research, I also have this opportunity to engage with industries on a day-to-day basis. So that's my journey so far. Now, if you look at what I do on a daily basis, as you know, I'm part of a university, which means I do teach, I do research, and obviously at my career level, I'm also taking up several leadership roles at University of Lincoln. Let me start with research. So with my research, as I said, it is heavily focused on space applications, where I work on planetary mobile rovers as well as orbital robotic manipulators. So we are working with several industries on developing in-orbit servicing, manufacturing, and assembly missions, where we need satellites with robotic manipulation capabilities to undertake servicing of satellites that are approaching their end of life cycle, or we need such robotic capture mechanisms for cleaning up of space debris. We are also working with industries to look at how we can use one or more space robots for assembling large modular space telescopes. So there are so many different applications of space that I'm part of, which is great. And I also have this opportunity to supervise students or PhD level and postdoctoral level researchers who are working with us on different projects. And considering that it is International Women in Engineering Day, I'm very pleased to say that I do have a few female engineers who are doing their research or PhD programs with me. So that's great. And here you can see the spectrum of application or sectors that I work on. So on one side, I would say 50% of my time is dedicated for space programs, whereas the other half is more focused on Earth-based applications. And I'm involved in application of flexible or soft robotic devices for surgical procedures, and we are working with a few clinical partners on those. We are also working on a range of other applications targeting the agri-food industry, nuclear, aerospace or inspection robots, and even terrestrial mining. So I'll give you a glimpse of this without going into the details of all the projects. Starting with space robotics, planetary exploration rovers is one of my interests. And here we are specializing in micro rovers. So we don't build large rovers like what NASA is doing. Rather, we look at developing innovative low-cost platforms which are intelligent enough to undertake long-range autonomous operations on Moon or Mars or other extraterrestrial bodies. And here again, I'm focusing more on the locomotion and chassis design. And some of my colleagues are helping me with developing the AI or the onboard autonomy software. As I said, we are also working with industries on upcoming missions, which are more looking at orbital robotics, that is looking at how we can design spacecraft with robotic manipulation capabilities for undertaking assembly, servicing, repair, refueling operations in space. And this is another very exciting time for us as space engineers, because the area of in-orbit servicing, manufacturing, assembly is now gaining a lot of momentum. And I believe this will happen in various other countries where your space agencies are supporting such missions. But there is a big hope that in near future, we will be able to be part of some of the upcoming missions, which are led by the UK space businesses. So this is a clip that shows some of our work connected
the slide
with...
is not shared yet, I think.
Sorry?
The PPT is not yet shared, I think.
You're not able to see my screen?
No, it's not yet shared.
Oh, that's weird.
No, ma'am, we can see your screen. It's okay.
Sorry?
Yes, ma'am, it's visible. The screen is visible right now.
Okay.
Can you see my screen now?
Yes, ma'am, we can see the screen.
Okay, cool. So I'm skipping that video. It's available in YouTube. So if you just search for Space Robotics Faster Project, you can watch a 30 minutes long video clip on our programs. Now, let me say a few words about how I ended up doing some very interesting work for the clinical community, where we are developing the flexible, minimally invasive robots for abdominal procedures. So when I started working on robotic manipulators, its design and control for space applications, there was an obvious question. So if I could do this for complex space missions, why can't I do it for other applications on Earth? And this made me talk to various clinical communities and also other leading research centers in the UK who are specializing in medical robotics. So with support from various other collaborators in the UK and also in Europe, we are able to secure a very large program funded by the European Commission to build a stiffness controllable flexible medical robot, which was tested initially in lab conditions and later on using human cadavers in the University of Dundee here in the UK. So we had various clinicians on board, and with this medical robot, this is a pneumatically actuated flexible robot with integrated force sensing capability. So as you will see in this video clip, the robot is able to sense the force it exerts on soft tissues. And based on this feedback, we are able to do real-time control to precisely maneuver the robot along any parts within our human body to undertake any surgical procedures. So here what you see is a procedure showing the electric, or in simple terms, it's to show how precisely we can move along a desired path which is defined by the surgeon to undertake any clinical procedure. So this was one of the previous projects which involved a lot of integration work a lot of innovative algorithm development, and some of our partners are now continuing the great work we did as part of the European Union funded STIFLOT program. Now, if we can do things for the clinical domain, yes, we can also support other engineering applications. So here in University of Lincoln, I'm also working closely with my colleagues who are part of the Lincoln Institute for Agri-Food Technology. And in Lincoln, we are doing extensive research in agri-food robotics. And my role here is to support my colleagues in designing innovative farming vehicles. So we are looking at how we can do the transformation from conventional tractors, which are emitting a lot of carbon. And we are looking at how we can move into fully electric farming robots. So on one side, I'm working with my engineering colleagues in designing autonomous robots, which are fully electrically driven. And I'm also working with my colleagues in computer science in developing what we need, that is the autonomy software to make these robots intelligent. So we are working towards designing our in-house robots, which are autonomous, and also which can be used for a range of agricultural applications such as autonomous weeding, autonomous harvesting, and we do have several other applications where ground robots may have to work in collaboration with aerial robots, or it could be in collaborations with other human operators or workers on the field. So this is a very large-scale activity in the University of Lincoln, and if you visit our webpage, you will see a lot of opportunities out there for agri-robotics people. And we are also part of UK's largest center for doctoral training, and we are having funded PhD degree programs for both home or UK students as well as for international students. And we do have a couple of students from India who are doing their PhD in agri-robotics with us, which is interesting. Now, it's also another exciting or more challenging domain, that is nuclear robotics. So I'm working with a few companies in terms of developing nuclear robotic devices or robotic manipulators to carry out very precise and safe handling of radioactive waste. So here our target or our focus is on developing haptic controlled robotic manipulators in collaboration with industry to sort and segregate nuclear waste. So on one side, with nuclear industries, as you can imagine, it is extremely dangerous to send human operators to sort out all the nuclear waste. So we are working towards developing an industry qualified system that can be used for sorting out different categories of nuclear waste and packaging them in the most safe way. So this is an ongoing project, and we are working with our external collaborators who are working with us towards developing the autonomous grasping capabilities for their Dexter robot. And at University of Lincoln, we are carrying out some exciting development in terms of, the AI or the autonomous software, the underlying teleoperation and haptic control software, which will be embedded on board this robot. And hopefully later this year or beginning of next year, we will be having some demonstration with the industrial manipulator. When it comes to engineering profession and being part of the academic world, we do have a great opportunity to interact with other experts at international level. And this is really important to disseminate the results of our research with the rest of the world. And if you love traveling, this is really a cool job for you, because you get the opportunity to travel all around the world to attend conferences where you can present your research findings with rest of the research community. You can learn from other experts and so forth. So I've been quite active in reaching out or collaborating with my international network from different countries with different agencies spanning the European Space Agency, NASA, JAXA, and so forth. Obviously, I do have some interactions with, but limited interactions with the Indian Space Research Organization as well. But disseminating our research is really important, and also supporting the global development of robotic and autonomous solutions, because especially with space programs or space missions, it's often international, and you need to collaborate with other experts to develop your ideas forward. So when we start working on some very adventurous mission concepts, it's not easy, because it takes time to evolve, to formalize, to consolidate your mission concept. And then obviously with support from industries or agencies, space agencies, you get that level of resources needed to undertake the research. And with international participation and engagement, we are able to make things happen. And that's why I really enjoy this international engagement aspect of my job, which helps us, stay connected with the rest of the developments in the world. Again, I was fortunate to teach several cohorts of students at University of Surrey. In my current role, I no longer teach students, but I'm supervising PhD and postdoctoral research students. But teaching is my passion, so occasionally I give some guest lectures. But otherwise, it's not something I'm continuing to do, but I was really fortunate to have taught several other cohorts of students, and especially the modules like space robotics, which I taught for more than 15 years. When I talk about research and women in engineering, it's important to, again, stay connected with our society, pass the message that engineering is not a profession limited to men. So for that reason, I have been very active in school outreach programs since 2005. So it's a long time since I've started visiting schools, talking about engineering as a profession, not limiting myself to educating female engineers, but also it's a profession that needs both men and women. And outreach and public engagement is an activity I'm continuing to do, and something that I enjoy very much. So to conclude my talk, I would say that having spent 25 years in space, I've found engineering, or my journey quite exciting. And because I'm working in a field that is very demanding, we often encounter several challenging projects on a day-to-day basis. It's a profession that is really adventurous. It keeps changing. Every day I'm doing something different. So it's not monotonous at all. And this is what makes my profession or my job, very rewarding. So as a space engineer specializing in robotics, control, and automation, I'm really proud to say that this is a profession that is very valid. And I would encourage more and more students, both boys and girls, doing their engineering degree to consider taking up a profession in space engineering and robotics. And within the field of robotics, there are so many opportunities out there. If you enjoy hands-on projects, you can really lead the development or the design of robots. Whereas if you're really good at software or coding, you can still work in the area of space or robotics, because we need programmers. So it is something that is useful, and we need more and more people to support the future development of robotics and space engineering. So with that, I think I will try to conclude my lecture, and I would like to take up questions from the audience. So your future is what you think or what you make it. And if you know your destiny, it's very easy to travel. So happy to take up any questions from the students or from the staff at CET. Thank you.
Yes, thank you, ma'am, for that wonderful session. Thank you for sharing your experiences and inspiring us. Yes, ma'am, we
Thank
have a
you.
question. Okay, could you just brief on how you landed on this profession?
It's a long journey, but I'll try to say it in 1 minute. So engineering, obviously, I was quite keen to do to study at CET. That I think I should phrase it that way, because as a child, I used to travel. What is that place called? Oh dear.
Srikaryam?
Srikaryam, and that.
Chavadimukh.
Yes. Chavadimukh. ആ റൂട്ട് വഴി ബസ്സിൽ പോകുമ്പോൾ നമ്മൾ എപ്പോഴും ഇങ്ങനെ കാണുന്നൊരു എന്താ പറയാ, ഒരു ഫാസിനേറ്റിംഗ് ബിൽഡിംഗ് ആയിരുന്നു CET. സോ അവിടെ പഠിക്കണം എന്നുള്ള ഒരു നമ്മൾ കുഞ്ഞുനാളിൽ നമുക്കൊരു ആകാംക്ഷ വരില്ലേ. So that was a thing that actually made me land at CET. And obviously, I lost interest in biology after my 10th standard, and I was only focusing on engineering. But once I did my BTech and MTech from CET, I did not, to be honest, I did not apply for a single campus placement. Believe me, I did not attend a single campus placement. When I think 98% of my classmates were, chasing companies to get a position, I was quite odd. I did not want to apply for a software job because I was quite determined that I want to specialize. I want to get a job that is space related. And for that reason, I opted to do my master's in control systems at CET. And I'm glad, I passed with very good marks and university first rank. And then it was very easy for me to identify a good offer from IIT Bombay to do my PhD. So that way, I got my doctor title, which I was quite keen right from my childhood. And my time at IIT opened up, several tracks for me to specialize further. And robotics was an area I found quite fascinating. And I'm glad I picked that, because that's why I'm here today, specializing in robotics and autonomous systems for space and for other applications. Hope that answered your question.
Yeah, thank you, ma'am. And any more questions from the participant side?
Maybe I can ask a question, if you don't mind. How many of the attendees, especially students, are really interested in robotics? That is, if you are really serious about a career in robotics, I would like to know, because we have several openings in the University of Lincoln. Maybe I will share my slide for a second. Okay, sorry, I think, let me see if I can open it up. Hope you can see this slide. We are recruiting continuously. And now we have a position that is open to people, our applicants with a master's level or a PhD level qualification. So you can join University of Lincoln as a research assistant or a postdoctoral research associate to work on a project, which is the nuclear robotics I mentioned in my talk. And this is a 32-month-long program. and you will be having an awesome opportunity to work with industries as well. So if you're considering a profession related to research and industry experience in robotics, have a look at our webpage. You need to apply online, so please don't send me your CVs. We will only accept applications submitted centrally through our recruitment webpage. So here is an immediate opportunity which will start from August. Okay, so I'm stopping to share my screen. Let's continue with questions if there are any more.
Thank you, ma'am, for sharing with us that opportunity. And I think the participants have got no more queries. Maybe they would ask them in the feedback form.
Okay, no problem.
Yeah, let me hand over the session to 𝘂𝘂𝙗𝙗.
Okay, so that was indeed a noteworthy and an inspiring session. I think there is one question from the audience. Yeah, you may please ask the question.
Sorry, I can't hear.
If any of the participants are interested to ask the questions, you may please unmute and ask.
Or if you could type your question on the chat box, I can try to take it up.
Okay, ma'am, shall we continue to the next session? I think he is facing some network issues. Yeah, 𝘂𝘂𝙗𝙗 again to you.
Okay. So it was really an encouraging and wonderful session to hear to your great experience in the field of robotics, control, and automation. So thank you so much, ma'am. Before everyone, now, last but not the least, let me invite Ms. Anita, student representative of IEEE RAS Kerala chapter, to propose the vote of thanks. Anita, please.
Very distinguished professor, many CSAT, respected guests, professional and student EXICOM members, dear attendees and my friends. I must say that we have been very privileged to listen to the words of a person who has got such an vast experience in the domain of space and robotics. We're extremely grateful to you for sparing your valuable time for us, sharing your experience and inspiring all those men and women present here. As a token of our gratitude, we would like to present you with a virtual memento. Thank you, ma'am. We look forward to hear more from you in the future. And on behalf of all present over here, I wish all the very best for your future endeavors. Thank you, ma'am, for inspiring
Thank you.
us. Now,
thank you for the invitation.
Now let me thank the professional EXICOM members of IEEE RAS Kerala chapter for giving us this great opportunity. Thank you all. And finally, but very importantly, a big thanks to all the student volunteers and attendees for all your support and active participation. Thank you all. We look forward to having you all again for our upcoming sessions. Thank you.
Thank you. Great to see you all virtually. Stay safe. Bye.
Yeah, thank you so much. Bye-bye.
Thank you, ma'am.